Hello. Mm. How are you guys doing today? Anybody
Pretty
there?
good. How
Yeah,
about you?
I'm doing okay. Just kind of hanging in, trying to find out what it was I just put on here that I want to show you. See if I can find it. There we go. Okay, let's try that one. Okay. Um, guys, I want to do a couple of things today. Sort of recap where we've been since the last test and sort of get us ready for what we're going to do and talk about the quizzes that you've had and look at those and make sure everybody's understanding what to do on those and talk about what we're going to do with quizzes going forward. I've tried to get these things graded, but it's getting increasingly difficult since they're coming in at different times, and I'm going to have to stop that actually. But let me um, let me bring these quizzes up. I'm waiting for. I haven't got but 3 people here. That's not a good showing yet. But I'll go ahead and share, and then maybe we can wait for people to come in. Uh, then I want to show you something about the calculator and so forth. All right, there's some more people. That's not what I want. Okay. I got Haley and Anai. That's good. Okay. We'll see what we got. So let's kind of recap where we've been. Whoa. somebody's either happy or unhappy. I'm not sure. Can't ever tell. Somebody else in. Let's see, Jennifer. Let's see. All right, got Jennifer in. Okay, so we'll let people in as they come. But let me talk about what we've done so far by way of knowing what you need to look at. This test is going to be on not a whole lot of material, and it's not particularly hard, but we're getting a little bit frazzled here at the end. At least I am, and I'm seeing it in you guys too, actually, in terms of being able to try to get all your work organized and getting it in. This test, I think I got everybody in here. This test starts at 5.1, and the reason I want to just talk about this is that no, not 5.1. It starts in 4. Sorry, starts in 4, where we talked about exponential functions, and the big thing we did in terms of exponential functions was talk about the e to the x function and how to take derivatives of that. So actually, we talked about, let's see, get up here. One more person to let in here. Emily. Okay. So I'm trying to let Emily in. There we go. Got her. Okay. So 4.1, and I'm just gonna write that right here. 4.
Are you gonna go over the quiz?
Say
Like,
that
are you going?
again. Yeah,
Are you
I'm going over. I am going over both of them actually. I'm going over that quiz, this quiz, and I'm going to go over one. Looks like I scanned them in the opposite order. No, okay, here we go.
I was under the impression that we didn't have to turn in the second quiz until 5 today.
Okay, that's fine. The second one was the derivatives quiz, or that was the antiderivatives quiz, right?
The antiderivative.
I am not talking about that right now. So you do still have time to turn that in. Okay, so this is just the prior to. Okay, so guys, on this test, the first thing we talked about was section 4.1, and that was just general exponential functions, y equal 2 to the x, and we talked about how to graph them and so forth and so on. Okay, the next section where we actually had a quiz was section 4.2. And 4.2 is where we talked about exponential functions, this special exponential function, which was e to the x, all right? We had a couple of formulas in here. We had all those compound interest formulas, 1 plus, if you remember, r over n to the nt, and I left out something here. Let me get that in there. A equal p, and we had a table where we filled that up, and that's one of the things I want to show you here. And we also said, well, the best you can do was this continuous compounding, which was PE to the RT. All right, let me let somebody else in here. Okay. I hate that there was all this security stuff, and we have to kind of individually let people in, but nobody asked me what I thought. So, and I don't like people crashing sites, so I guess that was necessary. Okay, so so section 4.1 was just general exponential functions. Section 4.2 was this e to the x, this special function, and we had two formulas that were really important. They were both, this one was compound interest with a finite number of periods. This was continuous compounding, which we said if we let the number of periods get bigger and bigger, this was the best we could do. So the first thing, this quiz, and this was a couple of quizzes ago, what I had asked you to do was, given this function, it's an exponential function, 2e to the 0.5t, it's just, I picked the values for you here, and you were to plug these into the calculator. So you're going to plug it in, just literally right to 0.5t, and you remember how you picked up e, you took ln, you took second ln, and you got e there. In a minute, I'll show you something I've figured out sort of late in the game, but about the calculator here. But that's what happened on that one. So if you need a key to that, it's right here. That graph, of course, was increasing and concave up. I've gotten back as many of these as I kind of identify. When you scan me homework, please rename it. When I just see scanned document, when I load it to my grader, I have no idea where it came from. So I have to go through another process of renaming it. So it'd be helpful if you would do that for me. So here, on this particular second problem here, we had some practice using these formulas. Now, I added late that t was equal to 5. So what it's saying is, how much money are we going to have if we compound this many times, once a year, twice a year, 4 times a year, 365 times a year, with a beginning principal of 350 and a rate of 4% for 5 years. Well, this formula, I'll just do one in sort of random here, and you can figure out the rest of them. Suppose I did quarterly compounding. It would look like 350 times 1 plus the interest rate was 0.04 over 4, all right, and then raised to the 4 times a year for 5 years. Okay, so 4 times 5 there is 20, and what I end up with, and again, I could not find my key to this when I was looking for it, but just make sure everybody's doing the right thing here. So that would be equal to, raise it to the 20th, and I get 427, my calculator's a mess, 427.07. So what I would get in there is that it's 427.07. Now, some of you didn't get the announcement that I had changed it to 5 years there. I left it there. I think Haley asked me, don't we need a time? And the answer was yes. Some of you used 1. But you do all of those. So if I did 365, there would be a division by 365 here, and then you'd have to say 5 years times 365. The continuous compounding is the one that used the A equal P e to the RT formula. Okay, and R in this case was 0.04, so that's the percentage rate. So 0.04, T was 5, and P was 350. All right, so when we do that one, we got 350 times E, and again, that's second ln, and it's going to be 0.04 times 5. See if I get a familiar answer here. And I got 427.49. Okay, so it's going up some. 427, let's say 49. So the problem was to fill in that table with all those things. And you'll have one virtually exactly like that, or comparing two rates or something on the test. Okay, and you got all the formulas there. This function, this right here, the demand function, what you needed to do, and I was just trying to see if you knew how to use your calculator here. It's 10,000. You're going to enter it like that. So 10,000 times 1 minus 3 divided by 3 plus e to the minus 0.00, see how many, 001, and t was, x was 1400. You really need to use a lot of parentheses here. This whole denominator needs to be in parentheses. It probably wouldn't hurt to put another big set around that, since it's 1 minus that. But the answer that that we came up here was something like, I don't know, 759 something. Okay. So that's a what, figuring out how to use your calculator is important there. So that's basically what we did with the exponential function. The next thing we did was a little bit of calculus on the exponential function. And that's what this next quiz was about. And I want to look at that one carefully, because I think some of you have some issues on that. So this was taking derivatives. Okay, if I've got your quiz or an attempt at it posted before class time today, I will count both of these quizzes. Hang on a second, I need to cut on a light. I can't see anything. There we go. Okay. So, question, before I go on to this one, guys, question about that one right there. Okay. Now's as good a time as any. Let me show you something with the calculator here, and it has to do with this problem right here. I am going to try to share something different on the screen here, guys. And if it doesn't work out, I'll come back like I normally was. But let me show you what I got here. Okay. All right, hang on. I'm gonna try to do something here. Okay. So I'm gonna. Oh, it's asking me the same crap it asked me before. Hang on. Let's do a new share. Let's do this and this, and see what happens. All right, you guys see anything?
Yeah.
You see the calculator?
Yes.
Yeah.
Okay, I just got this all loaded up to my satisfaction. Let me change a couple of things on it. I was working with a different class. I'm going to go down here. I can control it from the calculator thing. So then I'll just hit enter right here. I need to move that up a little bit. Let's see. Let's get rid of this. Over this way. Okay. So I'm going to hit enter. So I'm in function notation. If I go back to the calculator screen, which is what I essentially want to do. Suppose I want to figure out what that last problem was that I looked at. And we had $10,000. So I'm going to go with the $10,000 right there. And then we had some parentheses. And then we had 1. And it was minus. All right, let me go back. Yeah, minus is this key right here. Negative is that key right there. So minus. And then it had 3 divided by. And here's where I've got to start putting parentheses. Well, those not quite. Oh, God, I deleted the whole thing. Hang on. Shoot. That's not what I want either. Let's try this. Okay, I hadn't quite gotten used to it yet, but let me try again. So I'm multiplying 10,000 in parentheses, there was a 1. And then I was going to subtract and 3. And then divided by, and I want my parentheses here. And the parentheses say I'm going to have another 3. All right. And then plus, and some of you said you couldn't quite get this to work. I need to pick up E because I'm going to have E to a power here. So the way I pick up E is hit second ln. That's what we've been doing. And the power on E is what's going to go in that block right there. And the power on E is going to be minus 0.001. So there's the subtraction sign. So minus 0.001. And then it was times, they asked us to plug in 1400. Okay. So to bring it back down again, I can come down there. I can close my parentheses. Now I've got 1 minus and the division here, all of that is there. And when I enter, I wind up with 759.56. And that was the answer, guys. So more parentheses is better, okay? Put in as many parentheses as you can. To show you something else, if, suppose I wanted to graph something, let me clear these out. These were for another class. Let's clear that one. Let's go down and clear the next one. If I wanted to graph, for example, an exponential function, suppose I wanted to graph 5e to the 2x, okay? I would get the 5. My second ln would give me e. I want my power up here, it'll be 2. And there's your variable right there, 2x. Bring it back down. You might want to look at your window here. The window is a weird window because I was using it with another class. But if you want a standard window, like a 10 by 10 window, all you have to do is hit zoom standard. It'll give you a 10 by 10 window. Some of you have had more experience than with others, is it? And that's what that exponential function looks like. Okay. So if you're having trouble using your calculator, just drop me a line, and I'll set up a meeting with you, and we now can see it together. That's the whole nice part of this. They were giving this away free to people who started to teach online this semester because of the virus, and I just got it loaded up and figured it out. Okay, so I'm gonna go away from that for a minute and talk about the next quiz. So I'm gonna have to hook back up, do another share with a different animal, the one I've got here, and let's do that. So I'm gonna get this one, I'm gonna take this one away. All right. And then I'm gonna try to share my other screen that I'm used to sharing. I got that. I got that. Let's get rid of this. And yeah, there it is. Okay. So everybody okay with the calculator and that previous quiz? So that's the first part of what's on here. The second part was, how do we find the derivative of an exponential function? And if we want to find the derivative of an exponential function, the rule is right here. And it's a rule that works for all of them. If f of x is equal to e to a function of x, and that could be multiplied by 5 or 10 or 20, it doesn't matter. F prime of x, actually let's call this, I think I called this G in class, so let's just call it G now. F prime of x is going to be e to the g of x. It repeats itself and multiplies by the derivative of that power, and that power is a function. If it's just an x, the derivative of x is just 1. So we've got all our other rules in play here. So if I want to differentiate this, the first thing I need to see is that it's one function times another function. And in order to do that, I need to use the product rule. So the answer in this one should have looked like the first times the derivative of the second. Well, the derivative of e to the x is just e to the x, and the derivative of x is just 1. The simple form of this rule was just, if you've got f of x equal just an e to the x, then f prime is e to the x. Okay, So I'm using the product rule. So first times the derivative of the second plus second times the derivative of the first, which is 2x squared, and its derivative is 4x. So that's what that one looked like. This one was a great example of that first rule. You want to take the derivative of that. The derivative of a constant times anything is just that constant. It repeats itself in its original form. And then it multiplies by that, which is the derivative of that, which is minus 2x plus 5. So the 5 is just a constant. You don't have to use the product rule on it. It just stays there. You repeat this and then multiply by the derivative of that. Some people were treating it like it was a power rule or something, bringing that 2 down. No, that's not what you're doing here. This is totally different from the power rule. All right. The derivative of e to a function is that same thing, e to that function times the derivative of its power. So that's what that one looked like right there. Question about either of those? Anybody? All right, look at this next one. This next one, if you sort of rewrite it, it looks like f of x is 1/5 e to the 2x, all right, minus e to the x squared plus 3. The derivative is going to be 1/5. This repeats itself like it is and then multiplies by the derivative of its power. And the derivative of 2x is 2. So that's finished. The derivative of this next one right here repeats itself. The derivative of its power right there is 2x. So you're done with that one. The derivative of 3 is 0. So it just repeats itself. And I wrote that as a 1/5. Question, Haley? Mm-hmm. Say it again.
Can you explain that one more time? Because that. Can
This
you
one?
explain that one more time? Because that one, yeah, that one was the one that I didn't understand how to do.
All right. Do you understand why I just wrote this as 1/5? Because it's just a constant, okay? It's something divided by 5 is something multiplied by 1/5. And so I just rewrote that to make it look better. Now, the constant stays there because the derivative of a constant times a function is the constant times the derivative. So the derivative of e to the 2x, it repeats itself. And what's the derivative of its power? What's the derivative of 2x?
2.
2. So that's what happens there.
2.
Mm-hmm. So it's, if you were to rewrite it, it would look a little better if you said, well, 2 times a 5th is 2/5 e to the 2x. And it's not a power rule, guys. You're not bringing the 2 down. You're multiplying by the 2 here because it's the derivative of that power. Right here, the derivative of this one right here, it repeats itself. So it's identical. And then it multiplies by the derivative of its power. Well, its power is x squared. The derivative of x squared is x. How do I what?
So how did you get the derivative of x squared is 2x?
Well, that's a power rule. I mean, that's just like looking at another, that's like something we did at the very beginning. What's the derivative of x squared, guys? You're just looking at that. It's just 2x.
So you keep the x squared and bring the 2x down?
So, Stephanie, what did you say?
When you repeated the e x squared times 2x, so you keep the x squared and you bring the derivative down?
Yes, that's what the rule says. Look, the rule says this. If you've got something, if your function looks like e to a function, your derivative looks like this. It repeats itself, and then it takes this function right here and multiplies by its derivative.
Okay.
Okay. All right. I'll do another one. Hang on.
I'm sorry. Before you go on.
Yeah. What?
The 2/5. So then you multiply the 2 times 1/5 to get the 2/5.
Yeah. That's all I did. That's all I did there. Okay. And I didn't even have to do that, but that's what I did. So let me give you another one here. Suppose I had, I'll do it right. Suppose I had this one. Suppose I had f of x is 6 e to the x cubed minus x squared. The derivative would be 6. It's just a constant. This repeats itself, x cubed minus x squared. The whole thing just repeated itself. Now it's going to multiply by the derivative of that power. What's the derivative of x cubed minus x squared? What's the derivative of x cubed minus x squared?
3x minus 2x.
3x squared
3x
minus
squared. I'm sorry,
minus 2x. Okay, 3x squared minus 2x. Okay. All right, we okay with that? I got one more. I want to do this quotient rule one too, because some of you kind of got confused on the quotient rule and left some things out. All right, there's the rule. I'm going to get rid of that so I got room down here. This is a quotient. Quotient rule says bottom times the derivative of the top. What's the derivative of the top, guys? Anybody? It's just 5 minus top times the derivative of the bottom. Well, the derivative of the bottom is this and this. Well, what's the derivative of the first one here? What's the derivative of e to the x? E to the 3x, I'm sorry. What's the derivative? What does it do? What does it do?
3.
Well, e to the 3x, it repeats itself. Then it multiplies by the derivative of the power, which is
3.
And then the derivative of 4 is just 0. So you're looking at these as two individual pieces.
These are so hard.
Well, they're not hard if you know the rules and you know the quotient rule. Because it's really, Haley, what? So ask me again. What?
It's like whenever we see these problems, I don't know which rule to use because there's so many rules.
Listen, there's not that many rules because you're okay with the product rule and the quotient rule from before, from the first half of the semester. Those are not going to change. And you're okay with rules like you did on the last test where you just differentiating polynomials, okay? This E is a very different rule. It just stands by itself. You never use it unless you see this E business, okay? That's the only time you use this rule where you repeat it and you multiply by the derivative of its power. The other ones, you're just using the regular old power rule. If I ask you what's the derivative of x to the 5th, you're going to say 5x to the 4th. So if I had y equal, let me finish this one before I start talking again. Bottom times root of the top minus top times root of the bottom. Some of you left out the bottom. What is the bottom in the quotient rule?
It's the denominator squared.
Yes, it's the denominator squared. See, the quotient rule doesn't change. It's just that you've got some different functions in it. Maybe this will help. Let me try.
I got everything you got, but then you put minus 5x, and then in parentheses you put e to the 3x times 3. I got times 3e to the 4x, and I don't really know how I got that.
I don't either. I don't know why in the world your 3x changed to a 4x.
I don't know either.
Okay, I mean, it repeats itself. So if e to the 3x is going to repeat itself, it's not going to all of a sudden become e to the 4x. Okay.
Yeah.
Okay. So suppose I had this, guys. Forget about what we've done lately. Do you know what the derivative of x to the 5th is? What's the derivative of x to the 5th?
5x to the 4th.
Yeah. So don't go nuts on me here and forget everything you ever knew how to do, because I think everybody was okay with this. I have just introduced a new function. Now, suppose I said, now I want you to find the derivative of x to the 5th. It's a different rule. It's a different function. It's the only other different rule we've got. Y prime, when you have something like this, it repeats itself, just identical to what it is. And then multiplies by the derivative of its power. In that sense, it's kind of like this one, but it's working differently. It's a different thing. What's the derivative of x to the 5th? You just told me it was 5x to the 4th. Okay, so they're two totally different kinds of problems. The only new thing I've introduced is this e to the x function. Okay, let me finish up the rest of the this quiz, and then because Because again, you're kind of you're disconnecting the first half of the semester from the second half. And in light of what's happened, I understand that. But in this problem right here, it says find the slope of a tangent line to a curve. There's the curve right there at a point. What we have learned about the derivative is that it is the slope. And if you look back on that second test, I guess, first or second test, I'm still trying to figure out, I think I'm just going to have to regrade them all and post it to you because that's the only way I've got them. I got a whole nother class that they took their test before the break. I hand graded it, and now I'm gonna have to mail it to everybody because I can't scan anything else. I've got about scanned my brains out already. So whatever, we're trying to fix it though. But on the second test, if you were asked to, given a function, write the slope of the tangent line to the curve, you would have had a problem maybe that looked something like this. Let's look at, if I said, here's a curve, forget about that one right now, but here's a curve, f of x equal x squared, y equal x squared. And I said, here's a point on that curve, 2, 4. Find the slope of the tangent line to the curve at that point. So what you know is that the slope is given to you by the derivative. Well, what's the derivative of x squared? No big deal, no new functions. What's the derivative of x squared? Anybody?
2x.
2x. So if you want the slope at that point,
X.
yep, 2x, you just put in 2. 2 times 2 is 4. That's what the derivative gives you. It gives you the slope of that line. That's 4. So m equal 4. Now I ask you to write the equation of the tangent line. How do you write the equation of the line? Say it again. Question?
So is the slope 4?
Yes. Yes. That's what a derivative is. It's the slope of a tangent line to a curve at a point. Go back and read your notes from the second test, basically, from right before break. Okay? We had a quiz on that. We also had a problem like that on the test. And again, you don't have, I'll try to figure out what, you've got a copy of the test, I think, online, but that's, I mean, on Moodle, but that's about it. So here's how you write the equation of a line.
So you took the derivative.
You're breaking up, Haley. I'm sorry. What'd you say?
You took the derivative and then you got 2 times the x coordinate, which is 2.
Which was 4. Yeah, which is 2, and which gave you 4. So the slope of that thing right there is 4. All right, everybody, if I suppose I looked at the point minus 3, 9, and I said, what's the slope of the tangent line at that point? Well, the derivative is 2 times the x coordinate. So what's the slope, i.e. the derivative? What's the slope there at minus 3, 9?
Minus 6.
Yes, minus 6. Because you take the x coordinate of the point and you get that. Now, if I want to write the equation of a line, that's algebra, guys. Y minus the y coordinate equal the slope times x minus the x coordinate. We got a point 2, 4. We got a slope that is 4. Y minus the y coordinate is 4. Slope is 4. X minus the x coordinate is 2. That's the equation of a line. Now, let me go back to the problem. This was what we did before break. I now just have a new function. That's it. That's all I have. So it says, find the slope of the tangent line to this curve at the point 1. Okay, so what I've got to do is take the derivative of this function right here. I got to take the derivative of that function right there. Okay, what does it do? It takes the 5, it just stays there. It repeats the e to the minus 3x, and then it multiplies by the derivative of the power. Write it down. If you have trouble with it, write it down in words. Repeat it multiply it by the derivative of the power. Well, the derivative of minus 3x is minus 3. All I did was multiply those two things together. I got minus 3 times 5 is minus 15, e to the minus 3x. That is your derivative. Now it says find the slope of the tangent line of the curve at 1. Just like the one I did down here, if I found out the derivative was 2x and I wanted to do it at the point minus 3, I just put minus 3 in the place of x. In this problem, I'm just going to put 1 in the place of x. So minus 15 times e to the minus 3 times 1 is minus 3. I put it on the calculator. I get this. That is my slope. That is my slope. Put the x coordinate into the derivative. You get the slope. All right, I'm going to erase this. What did we do next? I asked you to write the equation of the line. You need a point. How do you find the point that goes with 1? You go to the original function. That's always what you do to find the y coordinate. The original function was this one, so it's 5e to the minus 3. That's how you get a point. I put that in there, I got 0.249. So the point we're trying to go through is 1.249. Now, I don't know if you're struggling with the fact that these are not whole numbers, they're decimal numbers. It doesn't matter, they're just numbers, okay? So this is your point right here. To find the slope, you had already plugged it into the derivative, so there's the slope. Equation of the tangent line is y minus the y coordinate equal to the slope, which was this, minus 0.747. That's a 4 times x minus the x coordinate. That's it. That's the equation of the line. No, it's not pretty, but
Could you solve that?
Can I?
Yeah.
Yeah, I can. Tell me what you would do. Tell me what you do.
I would distribute the minus 0.747 to the x minus 1.
All right. You're exactly right. See, you're not doing anything different there, Haley. So I'm going to do that. I'm going to say y, and I'll worry about this in a minute. 0.249. That's minus 0.747x. Minus a minus will be plus 0.747. And then if you want to solve for y, tell me what your next step would be.
Add 0.249.
Absolutely. Add 0.249. Absolutely. So here's what my line looks like. Minus 0.747x plus 169.996. That's your line. What's the y-intercept, guys? What's the y-intercept of this line?
996.996.
What's the slope?
Negative
7.
Yeah. And how did I get it? I took the derivative and plugged in the point. That's how I find slope of these weird curves. But that is just a line on this, that's a tangent line to that curve at the point 1. Okay.
Woo!
I know. That's what I did. That's what I just did. You couldn't hear it though. Questions, anybody? Go back over those tests. Go print them back off. Do whatever you have to do. See if you can rework them. And I will
Did you
try
freeze?
What's that? So what? Did I freeze? I don't know. Have I? Can everybody see me? Can anybody hear me?